next problem we're going to solve is we're going to do an optimization problem. We're given this water trough. This is a cross section of the water trough. And we can see that the dimensions of each side are 1 foot and the bottom is 1 foot and has some angle theta that goes from a perpendicular line from the bottom to the sides of the trough. Theta is the same on both sides. So the question is, what angle theta will give us the maximum volume? So the first thing we have to do is we have to write a function of volume in terms of theta. So what we're going to do is we're going to look at this shape and we're going to say, all right, which pieces do we have? We have 3 pieces. We have piece 1, we have piece 2, we have piece 3. So the volume of our shape is volume of 1 plus the volume of 2 plus the volume of 3. And from geometry, we can see that 1 and 2 are the same. So these 2 are the same, so we have just 2 of them. So we're going to get volume is a function of theta is equal to 2, call it V1 plus V3. Now our challenge is find V1 and find V3. V3 is pretty easy because it's just the area of this guy, and it's a rectangle, so the area of V3 is just going to be base times height, and the area of V1 is going to be, it's an area of a triangle, it's 1/2 base times height, so 1/2, I will call that little b times height. So the total volume is a function of theta is equal to this. So simplifying, the 2's cancel, and we're going to get V theta is equal to little b times the height plus b times the height. Now we just have to find what big B and h are in terms of theta. And using a little bit of trigonometry, that shouldn't be too hard. If we isolate this triangle right here, see we have some angle theta, and that's 1 foot there. From remembering our friend SOHCAHTOA, we know that this side y is going to be equal to 1, the hypotenuse, times cosine of the angle. So that's what y is equal to. We know x is going to be the hypotenuse times sine of the angle. So now we have the sides and we can fill in BH,
What is x?
BH. What's up?
What is x?
X is this side right here. Thank you. That triangle. So now we're going to find little b, and we know that little b is just this distance right here. So we have v is a function of theta is equal to little b, which is going to be sine theta, times big H, and big H is from here to there, which is just y, which is cosine theta, plus big B, which is this dimension right here, 1, times H, which we said H was y, and that's cosine theta. So now, rewriting all this, we know that our volume as a function of theta is equal to sine theta cosine theta plus cosine theta. So, yes?
If we're trying to maximize volume, why did we find the area?
Because we know that area is going to equal, volume is going to equal to our area times the length for shapes that are symmetric at any cross section, which is like the one we have here. So we have volume is going to be equal to area times length. So we find area, multiply it by some dimension, length, which call it L for now. I'll be able to find the volume. Make sense?
Mm-hmm.
So in order to maximize this, we know we need to take a derivative. It's sort of this whole topic that we're going over right now. So we're going to take the derivative of volume with respect to theta. And this all should be, this is volume over L, to be more specific, correct. Take derivative, v prime theta divided by L is going to equal to, we have a product of 2 things. We're going to use the product rule, which if this is the first and that's the second term, we know the product rule is first times derivative of the second plus second times derivative of the first. So plugging things in, the first term, sine theta, Second term, derivative of it is going to be negative sine theta plus the second, which is cosine theta, times the derivative of the first, which is cosine theta, plus the derivative of cosine, which is minus sine theta. Now we're left with this function, and to simplify it, we're going to say v prime theta over L. And for a maximizing problem, you take a derivative and you always set it equal to 0 because you want to find those maximum endpoints. So that's what I'm going to do. I'm going to say this guy is 0. 0 divided by L, still 0. So this guy is equal to 0. And he's going to equal my function over here. And simplify, that's going to be negative times positive, negative sine squared theta plus cosine squared theta minus sine theta. So looking at this problem, we have a sine squared theta, a sine theta, and a cosine squared theta. So what I'm going to do is I'm going to use the Pythagorean identity to get this guy, cosine squared theta, in terms of sine squared, so we can have all sines. Usually we can get trig problems with descending powers of sine squared to sine to the first. Sometimes we'll be able to use some tricks with trig that will make it beneficial if everything's in terms of sine. So what I'm going to do is I'm going to turn this guy, I'm going to replace him with 1 minus sine squared theta. And you can come up with that if you remember sine squared theta plus cosine squared theta equals 1. Solving for cosine squared theta, you'll end up with this. So now I'm going to pop that guy in. Minus sine theta minus sine squared theta. That's still equal to 0. So combining like terms, I have minus sine theta, combine those, minus 2 sine theta plus sine theta plus 1, and we know that's equal to 0.
Should it be negative 2 sine squared theta?
Yes, sine squared theta. So now what we can do, we have descending powers of sine, so we can use a substitution to go from sines to a variable that we're more comfortable with. We'll call it x for now. And we know this trick works because this sine sort of is acting as our variable because our variable theta is within sine. So what I'm going to do is I'll make a substitution. I'm going to say x is equal to sine theta. And we'll come back to that after. So this sine squared theta, he will turn into, we have two sines, so it's really negative 2 times x, which is just x squared. So we end up with 0 is equal to negative 2 x squared plus sine theta, we said it was equal to x, plus 1. And that's more easy for us to deal with. We know how to solve this. We can use quadratic equation. And if you do solve this with the quadratic equation, you'll get the positive answer to be x equals 1/2. And you can do that at home on your own calculator. So now what we're going to do is we're going to resubstitute x for sine theta. So we take this x, we replace him. We're going to say sine theta is equal to 1/2. And we're going to do a sine inverse, which replaces those two. Sine inverse of 1/2 is equal to 30 degrees. So we know that the maximum volume that we have is going to exist when our cross-sectional area has a theta value equal to 30 degrees.